Okay, here, Unit 2, Lesson 8, Problem Set 3. We're going to continue discussing the end behavior of a function, and with this one, we're going to look at some other features just to make sure that we have a clear distinction about where the end behavior really comes from. So consider the polynomial function y equals 2x to the fifth minus 5x to the fourth minus 30x cubed plus 5x squared plus 88x plus 60. The first thing we're asked to do is we're asked to determine the degree of the polynomial. So remember, when we look at degree, we have to make sure that our function is written in standard form. Standard form means we start with the highest degree term and go down to the lowest. So this is a degree 5, 4, 3, 2, 1, and then the constant is always a degree 0. So we're good to go. This is written in standard form. So to find the degree of the polynomial, it's really the degree of the leading term when it's written in standard form. So the degree of this polynomial is 5. This is a fifth degree polynomial. Okay, next what we're asked to do is determine which one of these terms, we have 6 terms here, which one of these is greatest whenever x is one of these values. And we start with an x value of 0. So to do that, what we're going to do is we're going to plug in 0 for each of these. And what we're asked to do is, if we evaluate each of these individually, which number is bigger? Well, this one is going to be a 0. This one's going to be a 0, 0, 0, 0. And this is going to be a 60. So which term is greatest? Well, it would be the constant of 60. And then we're asked to basically do the exact same thing for every one of these x values. I will pause the video again, much like we did the last time. And when we come back, I will have these all filled out, and then we can examine each of them. Okay, here are the results when we plug each of these x values into each one of these terms. We get these numbers, and what we want to do is we want to figure out for each one of these values, x equals 1, x equals 3, x equals 5, which one of these terms has the greatest output. So whenever x is 1, notice that this term of 88x has the largest output. So for for part A here, the term that was greatest when x was 0 was the term 60. For part B, the term that's greatest when x is 1 is the term 88x. For part C, I look through my list and I see that whenever x is 3, this term of 30x cubed is the greatest. So 30x cubed for part C. And then for part D, I notice that the 2x to the fifth term is the greatest. So what does this do for us? Well, what this helps us see, hopefully, is that it doesn't, the terms themselves, by themselves, the terms don't really have an effect on the end behavior. The only term, really important, the only term that affects the end behavior is the leading term. Okay, so if I look at that leading term and I see it's a degree 5, that is really the only term that's going to have an effect on my end behavior. So I'm going to come down here, and what we want to do is we want to describe the end behavior of our polynomial. So I'm going to write the polynomial out here just to make sure we have it, and it is y equals 2x to the fifth minus 5x to the fourth minus 30x cubed plus 5x squared plus 88x plus 60. So as we said, the only term that really has an effect on the end behavior should be this very first term. And notice, since the degree is odd, so I find the degree, and here I have an odd degree polynomial with a degree of 5. That means, from the very first video we did, that my end behavior should go opposite directions, down on the left and up on the right. So this is kind of what my end behavior should look like. So if I go ahead and sketch a graph that sort of looks like this, and remember in the beginning of the year we did a little bit of this graph sketching. My graph, I know it's going to go down on the left, up on the right, and it's probably going to have 4 different zeros. So we can just sketch that in. Uh-oh. 5 different zeros because it's a 5th degree polynomial. That makes more sense. And there should kind of be what our graph looks like, but notice my end behavior, it is down on the left and up on the right because I have an odd degree polynomial function.